All right, good morning. Today we're going to take a look at section 8.2, excuse me, and we start off with a definition, and that's for a parallelogram. So a parallelogram is a quadrilateral with two pairs of parallel sides. So remember, quadrilateral means four sides. So quadrilateral means four sides. And we've got two pairs of parallel sides. All right, so of course that would force the opposite sides then to be parallel to each other. All right, as you see in the diagram, remember the red arrows remind us that two lines are parallel to each other. So we have one set of parallel lines, another set of parallel lines, so two pairs of parallel lines. Okay, and there's some notation that goes along with parallelograms so that we don't have to write out the word repeatedly. And what we do is we just use this symbol, right, this symbol right here, whenever we want to denote a parallelogram. Okay, we use that symbol. A lot of times we like to abbreviate, especially really long words, so we don't have to repeatedly write that over and over and over. Okay, so there's our definition. And then immediately what follows is four theorems that go along with a parallelogram. So I'll put them all up on the screen at the same time. And then what you can do is just ask Miss Olson to pause the video as long as you need to so that you can get all four of these theorems down. Okay, I'll read through them with you, and then Miss Olson can pause the video and make sure everybody has a chance to get all four in their notebook. The first one, number 8.3, goes like this. If a quadrilateral is a parallelogram, then its opposite sides are equal. If we have a parallelogram, then its opposite sides are equal. Okay. Theorem number 8.4, if a quadrilateral is a parallelogram, then its opposite angles are equal. All right, its opposite angles are equal. Number 5, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Its consecutive angles are supplementary. Right? And this one follows, just as you're jotting this one down, this follows because consecutive angles right next to each other, goes all the way back to section 3.3. So if you went all the way back to section 3.3, we learned about consecutive interior angles. So now just the application in quadrilaterals, any consecutive angles are going to be supplementary, add up to 180 degrees. And then finally 8.6, if a quadrilateral is a parallelogram, then the diagonals bisect each other. Remember, bisect means cut into two equal pieces. They cut into two equal pieces. So essentially, four things are true if we have a parallelogram in front of us. All right? Opposite sides are equal. Opposite angles are equal. Consecutive angles are supplementary. And the diagonals bisect each other. Okay? So that's all of the new stuff for today. The definition of a parallelogram and the four theorems that go along with those. All right? If we had some time, or I think I gave you guys one of these in your assignment, we could actually do a proof of any of these. None of these are very difficult. None of these are too terribly bad. Okay? So now, again, ask Miss Olson to pause this screen as long as you need to get all four of those down. And then we'll move on to numerical problems. All right, so several examples of some numerical problems involving parallelograms. All right, so if I give you parallelogram A, B, C, D, and I tell you that this angle is 64 degrees, can you guys then find the measure of angle B, angle C, and angle D? Can you find the other three? As long as we have a parallelogram, parallel sides, parallel sides, can we find the other three angles? Only given one. And the answer is yes. All right, theorem 8.4 above says that opposite angles are equal. So if this angle is 64, the angle directly across is also going to be 64. Opposite angles are equal. And then theorem 8.5 says that consecutive angles are supplementary. So angles right next door to each other are supplementary. So that would mean that 64 plus b would add up to 180 degrees, which would allow us to subtract 64 to the other side of the equation, and therefore b would be equal to 116 degrees. And finally, we could get to d in a variety of ways, either using opposite angles. If this angle is 116, the one directly across is 116, or we could have just again used consecutive angles either from A to D or C to D. So there'd be a whole variety of ways to get to those answers. Okay? So if we're given a parallelogram, I need you guys to be able to find the missing angles. Now we could make that problem a little more difficult by just not having plain old angles like B, C, and D, but we can make them a little more complicated. So here's another one that's a little bit tougher. Again, I'm going to start you guys off with a parallelogram. So I'll just make that indication here so everybody's clear. Parallel sides. Parallel sides. And then on this one, I'm going to tell you that this angle is y minus 60 degrees. This one is x plus 14 degrees. This one down here is 56 degrees. Okay? And what I'm going to do this time is ask you to find just a couple of values. This time I'm only going to ask you to find x and y. Can you find the values for x and y? Okay? Again, I'm going to do this problem one way, but just keep in mind the majority of these problems can be done more than one way. So if you had a different idea, don't think you're wrong. There's more than one way to get to these. Okay? So how do we find the values for x and y? Well, because we have a parallelogram, theorem 8.4 says that opposite angles are equal. So therefore, 56 and x plus 14, those are opposite each other. Those then have to be equal. So we could say then that 56 is equal to x plus 14. And that gives you a very easy equation to solve. We just have to move plus 14 to the other side by subtraction. So the value for x then is 42. Okay? Then how would we get to the value for y? Well, we'd either have to use consecutive angles and theorem 8.5. So we'd have to use consecutive angles, two right next door to each other. We know that those are supplementary. Or we could also go from 56 over to this angle that doesn't have anything in it. So this lower right-hand angle. Again, the idea is any consecutive angles are supplementary. So 56 plus the missing one has to add up to 180. So therefore, we can move 56 to the other side by subtraction. And so our missing angle then must be 124. And if that one is 124, then we could go back to theorem 8.4, and remember that opposite angles are equal. And therefore, we could say then that y minus 60 would have to be equal to 124. And again, easy equation to solve. Move negative 60 to the other side by addition. And so y then would be equal to 184. And we'd have our two missing pieces. But again, a whole variety of ways in which we could get to the missing side. Oh, sorry, the missing angles. All right, sorry about that. Missing angles. Okay? So there's one. Here's another one that's going to be a little bit on the tougher side, again involving angles. Again, involving angles. We'll switch to the sides here in just a little bit. But here's another parallelogram. Again, I'll just continue to make notations of this just to, so that you're clear on that. So parallel sides, so parallelogram. And this time I'm going to tell you that this angle is 6G minus 14. This angle down here is 3G plus 5. And this angle over here is 9H minus 4. And again, I'm going to ask you to find two values, the value for G and the value for H. All right, so can we accomplish that? All right, can we accomplish that here? All right, and again, going back to the theorems, we have two that involve angles. 8.4 says that opposite angles are equal, and 8.5 says consecutive angles are supplementary. Right? Can we make either of those work? Well, the easiest one for all of us is always the opposite angles, but does that help us in this case? If I start you guys off with 3G plus 5, the angle opposite that is 9H minus 4. Now, theorem 8.4 says those are equal. So we could say that 3G plus 5 is equal to 9H minus 4. But can we solve that equation? One equation, two variables. Let me highlight. One variable right there, G. Second variable right there, H. One equation, two variables, bad. We can't solve. So we cannot start with opposite angles. What we have to do instead is we have to start with some consecutive angles. All right? We have to use 8.5 that says consecutive angles are supplementary. Now, question, should I pick these two supplementary? In fact, let me deluxe eraser that first arrow just to get it out of your guys' way. Question, should I pick this pair of consecutive angles? No, because when I add those together, because they're supplementary, when I add those together to get 180 degrees, again, I'd have one equation and two variables, not going to be able to solve. So I'm not going to start with those two. Instead, what I'm going to do is I'm going to start with these two. Those are still consecutive angles. Those are still consecutive angles. But what the theorem 8.5 says is those are supplementary. So if I add 6G minus 14 to 3G plus 5, I should get 180 as a result. And is that something we can solve? Yes, because it has how many variables altogether? Just one. Ding, 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 that's good for us, so we can solve. 6G's plus 3G's is 9G's. Negative 14 plus 5 is negative 9. So I can move negative 9 to the other side by addition. And divide both sides by 9. So G is going to be equal to 21. So one of our missing pieces is G being 21. Okay? Now to get H, we'd have to somehow figure that out, but even though it didn't do us any good to start with, the equation we began with that read 3G plus 5 equals 9H minus 4, even though we couldn't solve that right off the bat, now that I know what G is, now that I know G is 21, if I replace G with 21, please notice how many variables are left in the equation now. Just one. The only variable left is H, which means I can solve it. So 3 times 21 is 63, plus 5 more is 68. I can move negative 4 to the other side by addition, and divide both sides by 9. So H is equal to 8. And so the two values we're searching for then, guys, are G being 21 and H being 8. Okay, so those are a couple of examples using angles of a parallelogram, using angles of a parallelogram. Now, I want to do a couple more numerical examples with sides and diagonals. So let me give you a couple numerical examples with the other theorems. This is going to be a pretty easy one, but that's okay. So let's just start off with this fella. All right, oops, sorry, I forgot to make the arrows to remind everybody that we had a parallelogram. I'm going to keep doing that just to reinforce that. Okay, so now that I have that, now this side is going to be a 5, this side is going to be a 12, this side is going to be a y minus 5, and this side is going to be an x plus 2. And my questions will be, can you guys help me find the values for x and y? Right? And pretty easy, as long as you look back to theorem 8.3. In 8.3, the theorem says, if we have a parallelogram, its opposite sides are equal. Opposite sides are equal. So that means that these two sides, the y minus 5 and the 12, have to be equal to each other. Also, while we're at it, these two opposite sides have to be equal. So 5 and x plus 2 have to be equal, giving us two very simple equations to solve. Move negative 5 to the other side by addition. So y is equal to 17. And move plus 2 to the other side by subtraction. So x is equal to 3. So our two missing pieces, pretty simple to find. 3 for x, and 17 for y. Okay, opposite sides have to be equal. Let me just give you another one of those. Right, let me give you another one of those, folks. Here's another parallelogram. Again, opposite sides are parallel to each other, so parallel there, parallel there. And this time I'm just going to simply give you this side 13k minus 9, this side 5k plus 7. And this time instead of 2, I'm just going to ask you for one missing piece. So can you find the value for k? Again, theorem 8.3. If we have a parallelogram, opposite sides are equal. So these two opposite sides, 13k minus 9 and 5k plus 7, have to be equal to each other. So that again gives you an equation in just one variable, so you can solve. So variables to one side, numbers to the other. I'll choose to move the variables to the left-hand side. So I have to move positive 5k to the left, so I subtract. 13 minus 5 is 8. And if I move the variables to the left, the numbers have to go to the right. So I'm going to move negative 9 to the other side by addition. Get rid of times 8 by division. So k is going to be equal to 2. All right, k would be equal to 2. Okay. And finally, I want to give you an example of a problem with, what number is that? Theorem 8.6. So let me give you a numerical example there, so that you have at least one example with all of the different theorems. So again, what we're going to start off with is a parallelogram. So parallel sides and parallel sides. Then what we're going to do is we're going to put in the diagonals, and I'm just going to put those in a different color just so your eye can catch them easy. So the diagonals I'm going to put in blue, and then I'm going to give you the lengths of the different pieces. So this piece of the diagonal is 5q minus 11. This one is 3q plus 5. And then on the other diagonal, this one is going to be 6p minus 10. And this one is 3p plus 2. And then what I'll ask of you is to find the value for p and the value for q. Now with theorem 8.6 says, if we have a parallelogram, the diagonals bisect each other. Now remember, please, that the word bisect means cut into two equal pieces. So the shorter of the two diagonals gets cut into two equal pieces. I'll try to put a couple of red tick marks on there, so those two pieces have to be equal. And the longer diagonal gets bisected, so that one gets cut into two equal pieces. So what that allows you to do then is it allows you to say, well, this segment, 5q minus 11, is equal to this segment, 3q plus 5. All right, or I could have said that differently. 1/2 of that diagonal has to be equal to the other half. And then similarly, on the shorter diagonal, this half of the diagonal, 6p minus 10, has to be equal to this half of the diagonal, 3p plus 2. Again, both of these very easy equations to solve. Variables to one side, numbers to the other, and divide. So in this case, q would be equal to 8. And in the other equation, variables to one side, numbers to the other, and divide. So what we end up with is p equaling 4 and q equaling 8. So p equals 4 and q equals 8. All right? Sound okay with everybody? Sound all right? Okay. And then we're going to finish off with one more problem. And I'll guarantee you I'm going to put something like this. I'm going to put something like this on your test, eventually when we get here to the end of chapter 8. Guarantee I'll put something similar to this on your test. So it looks like a tough one. So one last numerical example. So let me get a parallelogram in first. That's a little shaky. I'm going to do that better. I think that looks a titch better. So again, parallel sides, this way and this way. All right, so the parallel sides. Immediately I'm going to put in the diagonals. So put in all of those diagonals. There we go. And then what I'm going to do is I'm going to give you the measure of 3 angles. This angle right here is going to be 80. This angle 117. And this angle 23. And then in red, I'm going to name all of the other angles. So I'm going to name 1, 2, 3, 4, 5, 6, 7, 8, and 9. And what I'd like you to do is help me find the measures of all 9 of those angles. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Sounds like it's going to be quite the undertaking, but in truth, lots of them are easy. There's only a couple that are a little bit on the tougher side. So I need you to keep a couple things in mind, like opposite angles are equal, consecutive angles are supplementary, but then I need you to keep in mind a few older ideas like vertical angles and linear pairs. Vertical angles and linear pairs. Okay? All right, so I'm just going to make sure everyone has a chance to get the picture down, and then we're going to work ourselves through finding all 9 missing angles. Okay? All right. If I'm going too fast, you can ask Miss Olson to pause the video so that you can get the diagram, the picture down. Okay? So where could we get started? Well, if you wanted to, we could get started with a couple of easier ones, or what I hope are a couple of easier ones. Like, if this angle in the center where the diagonals intersect, if this angle right here is 117, the one opposite it, in this case, angle 5, is going to be what measure, guys? If this angle is 117, the one directly across is going to be 117. Why? Because the 117 and angle number 5 are vertical angles. They're vertical angles, so they have to be equal to each other. All right? So that's an easy place to start. Another one that's pretty easy is if you remember that any two angles right next to each other like that, along a straight line, form what's called a linear pair. And a linear pair means two angles that are adjacent to each other that add up to 180 degrees. So what we would know is that angle 4 plus 117 has to equal 180. And that allows us to then solve for 4 by subtracting 117 degrees from both sides. Therefore, angle 4 has to be 63 degrees. Right? And if it's helpful, I could include those numbers as we go. So 5 is 117, 4 is 63. Any of those, feel free to include in your picture. That then allows us to get number 6 very easily because 4 and 6 are vertical angles. So those opposite angles must be equal to each other. They must be equal to each other. Okay? So we're doing pretty well. We're doing pretty well. Where else could we go, guys? Where else could we go? Well, if we wanted to, we could do something like this, or you could save this for later, but whatever works for you guys. We could consider one of the triangles formed within this picture that I'll try to outline in green. And within that green triangle, how many of the angles do you know now? You know 2. One angle is 80, the other angle is 63. So therefore, we could find angle 1, remembering that the 3 interior angles of a triangle add up to 180. So we could say that angle 1 plus 63 plus 80 has to be equal to 180. And that's a pretty easy equation to solve. 63 and 80 is 143. And then move 143 to the other side by subtraction. So therefore, angle 1 then has to be 37 degrees. So you can tell we're just kind of plunking away. We're plunking away getting some of our answers. We could do something similar with the top triangle. I don't know how many colors I have left here, but I could outline this one in yellow as an example. So kind of the triangle at the top of the picture. And again, what we would know in that yellow triangle is 2 out of the 3 angles. All right, we'd know 2 out of the 3 angles. So we could find the third one by, again, remembering that the 3 interior angles add up to 180. So let me just shrink this up slightly because I'm going to need some more room to work. All right, so in the yellow triangle then, we'd know that 117 plus 23 plus, number 3, add up to 180. So 117 and 123 is what? 140? Yeah, 140. And then we could move 140 to the other side by subtraction. So angle 3 then has to be equal to 40. Right? Seeing how that works okay? Seeing how that works? Okay, hope so. Hope that's making some sense. And then we could do something like this. We could make kind of a jump. As an example, let's see, I got to pick something different. How about a purple? Let me find the purple in there somewhere. All right, if I find purple, what I could do then is highlight 2 angles. Just as an example, I could highlight this angle, that big angle, and this one right here. And would you guys understand that those 2 are consecutive angles inside the original parallelogram? So therefore, those 2 angles have to add up to 180. So the first of those plus the second of those has to add up to 180. Now the first one is made up of an 80 and a 40, which would be 120. The second one is made up of 23 plus whatever angle 7 is. So you see how I did that? I put 80 and 40 together for that one. Then I put 23 and 7 together, but I don't know what angle 7 is, so I could figure it out. 120 and 23 is 143. And then move 143 to the other side by subtraction. So angle 7 then is going to be equal to 37 degrees. Again, just continuing to work ourselves around the triangle. So now angle 7 is going to be equal to 37. And I'm just keeping an eye on my time, and I'm running a little long because I know this is supposed to be shown on Wednesday, and Wednesday's our short day. So I'm just going to try to pick up the pace a little bit. We could then go in, while I'm in purple, I could actually highlight a purple triangle to the right. And again, I'd be in a situation where I know 2 out of the 3 angles in the purple triangle. So I could add them together, and they have to add up to 180. So 63 plus 37 plus number 8 has to add up to 180. 63 and 37 is 100. So move 100 to the other side by subtraction. So 8 is equal to 80. Is equal to 80. Okay? Excuse me again. All right, and then, oh man, I'm really running low on colors here. 8, what was that one? That one was again 80. Okay, and then again, I could make the jump from, I gotta seriously pick a new color. I think green will work though. Now what I need to do, guys, is go from an angle like this one in the parallelogram to this one in the parallelogram. All right, and I'm going to scooch this over so I have some room to work. And then if we use the theorem, excuse me, theorem 8.5, consecutive angles are supplementary. So if I add those 2 angles together, they add up to 180. Now one of those, this top green, is 23 plus 37, so together that's 60. And then the other green one is made up of 80 degrees plus angle 9. So again, it allows us to solve 60 and 80 is 140. And then we can move the 140 to the other side by subtraction. So angle 9 then is equal to 40. And finally, get rid of that color bar. Then we could look at the triangle on the bottom. And again, we know 2 out of the 3 angles. We know one angle is 117 and the other one is 40. So whatever's left over has to be 23. Okay? So I know I'm running a little bit late, but I wanted to do a pretty tough one there at the end before we were done for today. Okay, so we're all done with section 2. We're all done with section 2, so you can work on that one, and that assignment then will be due tomorrow. So please send that one to me electronically, all right, by tomorrow afternoon. Okay? So I got to get off here quick because I'm running out of time. So have a good day, and we'll talk to you guys again soon. See ya.